Now, after having computed AVE and CR, we will now do the discriminant validity check, right? So we now want to test whether these three factors, EMP, task orientation, and LEX, whether they are discriminant to each other or not. So let us do that, and we will now do discriminant validity check. Okay, so remember we said we will create a table, task orientation and leading by example. Similarly, we'll have EMP, task orientation and leading by example. On the diagonal, we will write the average variance extracted for each of these constructs. So this is the average variance extracted for the three constructs. So 0.672 is for EMP, 0.678 is for task orientation, and 0.545 is for LEX. Below the diagonal, we will write the interfactor correlation. Now, where do you get this result, interfactor correlation? We will get it in our AMOS output, the estimates. Right, so we got the standardized regression weights. Below this, you will see there are covariances and correlations. So this is where we will get the correlations. We need to write the correlation. So what is the correlation between EMP and task orientation? It is 0.665. 0.665. Then what is the correlation between EMP and LEX? It is 0.611. And then what is the correlation between task orientation and LEX? It is 0.785. Right? So this is, let me also make it 2 decimal places so that we don't do, yeah. Okay, and I will send that. So this is our okay, this is our AV, this is our let me just do the like this is average variance extracted then right, so this becomes your square of, so let us now compute the square of the interfactor correlation. So this multiplied with this is the number 0.44. Then you have EMP with LEX, so the correlation is 0.61 multiplied with 0.61. This is the square of the correlation, and then 0.79 LEX and task orientation. This is the okay. So now we have got average variance extracted, interfactor correlation also, and the square of the interfactor correlation. Now, what are the discriminancy conditions? This validity checks. So we said AVE of EMP should be greater than the square of task orientation, the square of the correlation with task orientation, and square of the correlation with LEX, right? So R square, so let me call this as R square EMP with task orientation, and R square, the correlation square of EMP with LEX. Then we also said AVE for task orientation should be greater than R square EMP task orientation and the R square of LEX with task orientation, and then AVE for LEX should be greater than the correlation square of EMP with LEX and R square of LEX with task orientation. Now, the first condition, EMP, AVE, AVE of EMP is 0.67, it is greater than 0.44, it is greater than 0.37. So this condition passes. The second one, AVE of task orientation, 0.68, should be greater than R square of EMP with task orientation, which is 0.44, and R square of LEX with task orientation, which is 0.62. So this condition passes. Then the third is AVE of LEX should be greater than R square of EMP with LEX, which is 0.37. And it should also be greater than R square of LEX with task orientation. So 0.55 is greater than 0.37, it is okay, but 0.55 is not greater than 0.62. So this condition now, it fails. Right, so now what we have got is that there is at least one construct LEX which is not distinct from the other one, which is task orientation. That means there is high interfactor correlation in this case. So what does this show? It shows that either you merge both these factors, okay, and model one factor LEX or task orientation, or you model a second order latent factor. Now merging, as I was also saying in an earlier discussion, in a previous discussion, that merging the two factors does not make too much of a sense, because what will you call the merged factor LEX in task orientation? Rather, what you should do in such cases is you should go ahead and model a second order latent factor. But again, it is your discretion. If you can justify what your merged construct would be, okay, it is absolutely okay. You can go ahead and model the merged factor of task orientation and LEX. However, in this case, in our example, we are now going to model a second order latent factor having the three first order factors: EMP, task orientation, and